So today I'm going to go over, uh, tie up a few things that we didn't finish up because of some of the complexities to it. But what we're going to do now is we're going to go over a little bit of more of lines, and then we're going to get back into some advanced dimensioning since we've just talked about tolerance. And so we're going to go to there and see if we can't, finish up some things here. So the first thing I wanted to do is go back here where we were back on line conventions. We learned about center lines and hidden lines and object lines and construction lines and all sorts of other things. Well, I said we were going to come back to these. So the other day we did a section view, and here you can see the section lines. So those are section lines. And you have to remember that Project Lead the Way is going to try to sucker you into thinking that that the section lines are the cutting plane lines. So you have to be very careful with that and know what the difference is. Okay, this is a short break line. This is where like the Incredible Hulk came in here and just reached in and went "Arr!" and just ripped the thing out. And so you can see it's a short break line right there that represents where part of this piece was taken out and broken out. So dimension lines show the actual dimension. We've talked about that. We've placed those on some of our work now. And so dimension lines have the actual distance of what the object is. We don't include inch marks. We are Americans. We think that everybody uses inches, so we assume that these are going to be inches unless it's otherwise stated. Okay, extension lines extend out, they never touch. Okay, long break line. So this you can see it's marked as 12 inches long, but that this is not actually drawn at 12 inches, right? So right here we can see each one of these is a quarter of an inch, right? So this is 1 1/4. That certainly is not 12 blocks. That's certainly not 12 inches long. So what they do is that this area right in here is all the same. So they just say, well, we can fit it on a smaller sheet of paper if we just use these break lines and we don't have this big long piece that's going out there. So that's a long break line. And an inventor will do this. Okay, so leader line, we are just going to get into leader lines now. We've talked a little bit about leader lines. Leader lines are just like extension dimension lines. They are thin, they are jet black, okay, and they always point to the center. So in this case, they're diameters, and they come up to the object that it's pointing to, and it points directly to the center of the object. All right, leader lines with a radius, and radius is marked with R. Notice that these diameters are marked with a theta sign here. That's the symbol for that is the symbol for diameter. A capital R is for radius. A radius would point to the center, and it would go all the way to the center. It would point to the arc, but then the line would extend down to the center, and hopefully we'll see one of those. Okay, so these are all done with standards, and it's done, to relate different techniques and ideas. And there is a certain hierarchy that goes into things. Object lines take precedent over hidden lines and center lines. Hidden lines take precedent over center lines, and a cutting plane line takes a precedent over all others. Okay, so precedence of lines, you can see here, here's an object line. And if we go down here, there's an actual hidden line that's there for the circle, for that hole. Right here, you can see the hidden lines, but the object line here is in the way of the center line. You can see that they've come out here with the center, part of the center line here and part of the center line here, but the object line takes precedent. All right, so that takes care of that one for now. And so let's go back into here. We're going to come back here into, so this is going to take me a bit. Don't really go there. All right, this is going to take me a bit to get, hopefully we're going to be in the right place. Okay, so here on this slide, there's a number of things that are going on here. And I wish this thing would go away sometimes. And I can't even move it, which really bugs me. So here we're going to add our leader lines. I'm going to just go through this because we already talked about crossing, not crossing dimension lines. So here we can see leader lines down here. We have a radius of, sorry about that, we have a radius of 0.25 and a hole that is through, T-H-R-U, yes, that's through, with a leader line there. And you notice that the radius is pointing to the center of that arc. Okay, there is no center mark there because it's a small radius. Now, normally, if there's a larger radius, we're going to put a center line in there, and we'll talk about that later. Okay, here you can see leader lines. We're always trying to avoid crossing other lines. We're trying to avoid crossing leader lines. So we're going to drop this one down here to the bottom, get it away. Yes, I know it's not in between views, but that's a much better, much cleaner area to place that. Okay. Here, leader lines are the way they point, they're always on an angle. You can make them really just about any angle as long as you can see here that this is pointing directly to the center. This is not acceptable. This is not acceptable where you have horizontal or vertical leader lines. So not acceptable. All right. Here we've got what we call symmetrical dimensioning. So I want you to write that down. Symmetrical dimensioning. That is a test question that I will have from you. In symmetrical dimensioning, you can see here where they stack them all one right after another. This is used here with a bunch of cylinders that come out from one another, and it's a much easier way. But when we get something like this, what we're going to do is we're going to stagger the dimensions. That way they don't run into each other, and it looks much nicer. We don't want, some of you might have found that with your puzzle project, that sometimes the dimensions got into places where it was like, that's a little bit weird, a little bit odd, doesn't look really good. You can move those dimensions around. Okay, in general, a circle is dimensioned by its diameter and an arc by its radius. Okay, so that is correct there. Holes should be located and sized in the view that shows the feature. So when we dimension a hole, you can see here, this is technically dimensioning to a hidden line here. This is not dimensioning to the shape. Here is the shape down here. So when we do this, we want to make sure that we take those dimensions and we place them, we place them in the correct place. So you have to locate the center and you have to give the size. So there's a number of different things that you need with a hole. You need to locate both the horizontal and vertical center. You need to give the diameter of the hole, and you need to give the depth of the hole. Okay, so those are all things. Write those down. Locate, diameter, and depth. All right, holes are located by their center lines. So when we take a center line here, you're going to use those and extend those out and use those as extension lines. You can see how they brought them out here, and then we can add in our dimensions. All right, that's it for that one. And so now we're going to get into a little bit more advanced dimensioning. We're going to talk about this. All right, so some more dimensioning standards here. Now remember, dimensioning is through all this, everything that we do is all through a standard, ANSI. There's also ISO, military, Department of Defense, Deutsch, Japanese, so it depends on where you are. Project Lead the Way is going to ask you to know these two, the International Organization for Standardization and the American National Standards Institute. You have to know those. Okay, there's also, though, Department of Defense military standards. This is Deutsch for German, okay, Japanese industrial standards, and the European standards. And they're all pretty much the same. Okay, we've already gone through these lines, so we're going to continue on here. All right, but here we can see that this 1 inch doesn't fit. So we need to go ahead and pull that out and make sure that it fits and looks more professional. All right. So dimension text guidelines, dimensions text is placed in the middle of the line, both horizontally. Okay, now this is known as unidirectional dimensioning. Okay, uni meaning one, all the dimensions are read from the bottom. Now the Europeans, as you've already seen with your with your puzzle project, they do what's called align. So anything that is a vertical dimension, like the 3, the 150, they actually turn that dimension and align it with the dimension line. So that is called align. That's going to be a quiz question from you. Okay? All right. So dimensioning methods, unidirectional and aligned. Let's take a look at those. So here's unidirectional. Everything is read from the bottom, and aligned, it aligns with the dimension line. Okay, so these all align with the dimension line, that aligns with the dimension lines. Now, if I had a dimension over here, it would not face, we would not read it from the left side, we would still read it from the right. So in aligned, you're reading it from the bottom and from the right only. Okay, there are size and location dimensions. Again, another question that I'm going to ask you. Size gives a size, all right? Location locates something. A center mark is always a location dimension. This gives us a size. It tells us how big something is. What is the distance between these two centers? Okay, this is a size. That is actually going to be, if this were metal, we would use a milling machine, and we would have a 0.52 mil, and we would bring it down in here, and we would mill directly over here and stop it over here. Okay, this is a location. We're locating the center. All right, so size and location. Linear dimensions, chain dimensioning. All right, so let's take a look at chain dimensioning now. Anthony, what is wrong with this? What is wrong with this dimensioning right here? Somebody please tell me. I hope you all said that it was not dimensioned to the shape and it was outside of views. Okay, I would absolutely crush somebody on this. These dimensions should be over here. So that should not happen. This is really a type of dimensioning that we will almost never use. Okay, we'll always use in chain dimensioning. We will go one right after the other and then do the overall. This gives us a, this is used quite a bit in civil engineering and architecture. This is an absolute no-no right here. These two should go over here where the shape is. And you'll hear me talk about Anthony all the time because Anthony is the one that drew this. So we'll talk about that in a minute here. All right, datum dimensioning is from a single point called a datum. All right, reduced dimensional deviation, because in other words, the tolerancing is better. When we go here, if we're off by 1/10 of an inch, we're off by 1/10 of an inch. If we come over here and we're off by 1/10 of an inch, now we're off by 2/10 of an inch. If we come over to here and we're off by 1/10 of an inch, now we're off by 3/10 of an inch. Okay, so very important for you guys to understand that chain dimensioning is not very accurate. Where datum dimensioning, if we come off over here at 1/10 of an inch, we're off by 1/10 of an inch. If we come from here to here, we're still only off by 1/10 of an inch because we haven't added that 1/10 here. And the same thing here. So you can see here's where we get this whole Anthony thing, and we kid about Anthony. Again, here Anthony is screwing up. Anthony should have these dimensions over here to the front view where it shows shape. Okay, I would take this sheet right here, and you need to print this out. I use these symbols all the time on your drawings. Okay, degrees, reference symbol. Now we talked about reference the other day with dimensioning, with tolerancing. Diameter symbol, the radius. This is a counterbore. We talked about the counterbore or spot face. Remember we talked about what that is, and that's a counterbore right there. Okay, countersink, basically like a counterbore, but just V's down. This tells depth. This tells how many times that you might place that particular dimension. We're going to get to that here in a little bit. Plus or minus symbol for tolerancing. Center line. When you see this on your drawing, that means that you have to place a center line in there. Here's some of those GDTs that we talked about: squareness, arc, and slope, and there were some other GDT symbols that we talked about with that. All right, two ways of dimensioning angles. Okay, one is coordinates. Find the point, connect the dots. Okay, and sometimes that's a much better method of using it. And when we do large areas, this is generally what we use. We'll use connect the dots to do that. Another method, though, is to use the angular method, find one point and then the angle. And sometimes this is more important, that the angle is more important than the points themselves. So what we do here is you would click on, you can click on this line in Inventor. You click on this line with your dimension tool, click on this line with your dimension tool, and then pull this out and your 30 degrees comes out here, or whatever your angle might be. All right, so two different methods. All right, dimensioning chamfers. Inventor has a chamfer tool. And what you do is you click on the chamfer itself, you click on a referencing edge, it comes out, it tells you what that chamfer is. You can also do it as far as saying, okay, 45 degrees by 1/8 of an inch, or 1/8 of an inch by 1/8 of an inch, or 125 thousandths there. Okay. Here you can see that this chamfer is done for this countersink here. It's done with the diameter this way, which is really improper. But then they put the angle over here. And another way of doing chamfers again is to do the dimension and then the angle. All right, dimensioning arcs and circles. Arcs and circles are dimensioned in views that show that shape. Okay, arcs are dimensioned with a leader and identified as radius. In some cases, a center mark is included. Anything that's a large radius, you must put a center mark in. Circles should have a center mark and are dimensioned with leader identified by their diameter. The reason we don't identify them by their diameter is because we use drills, and drill bits, they are labeled by their diameter. So let's take a look. Here's a small radius. This is a fillet and round. Now, normally what you would do on a drawing, especially if it had plenty of rounds and fillets, this is a round because it's convex, okay? So normally what we do is we would just write down, note all fillets and rounds are 125 thousandths unless otherwise specified. So over here, this is what I was talking about earlier, is that your leader can come from the center point and go out. This is a larger arc. It has a center mark. Now, this is incorrect what they've done here. What they should have here is they should have a line here. They should have a extended out the center line here and the center line here. Again, Anthony must have done this and not put that in correctly. So here, this is one way. You can also make your radius out here and bring this line all the way down in. Either way is acceptable. All right, here you can see where the radius is placed in here. You can see that the radius is placed in here, no center mark. Here, the center mark, that should extend out 1/8 of an inch and extend down 1/8 of an inch. That should not happen here. Small rounds, they do not have center marks. Okay, here again, if you're going to do this, you're going to bring your extension line in, you're going to bring your extension line, your center line in, your center line down 1/8 of an inch past what it is representing. But these are fillets. Fillets are concaved, rounds are convex. All right, dimensioning two circles. And again, here we just did this the other day with our tolerance. So we went from center point to center point and placed those in there. But you can see that a full circle. Now, we don't do the double arrow here, but you can see that it's dimensioned by its diameter. Here you can see the radius. You can see that this is pointing to the center. When we have something smaller like that, we generally won't bring our leader line all the way to the center, but in a lot of cases we will. And here again, you can see diameter with the depth of the hole. So the hole goes down 1 inch. Okay, again, symmetric dimensioning here, and here's what they told you not to do, is line them all up. So, and again, here, I would probably bring this, you could bring this 0.67, you could bring it over here. What they're doing though is acceptable and fine as far as that's concerned. Dimensioning splines, we try to avoid splines completely. What's much better is to link arcs and tangent the arcs in, because we have to break these down, and usually we do it by inch or by ½ inch or by ¼ inch or whatever the case might be. And in this case they have a 5.3 and I'm not sure why they have a 5.3. If this is 3.0 here, there should probably be, if you're going to do that, probably a 5. and then a 7, and then an 8. 8.5 is probably fine. You still need to know what this final length is here. But you can see that it's very unscientific, to do that. So we really, yes, even in the airline industry, even in the airplane industry, they try to link arcs. Okay, here again, you can see another example of that being done with this toy. And you can see, here's your section lines in here that go in there. This is a very bad datum. I disagree 100% with this. Datums should not start out with an edge like this. If this area here is straight, this should be your datum line. That absolutely should not happen, Anthony. So Anthony's got to get his act together here. Not sure if I agree with this either. I would probably have one datum line coming out here and then working the way up. And you notice here that they put all of these in as reference lines, reference dimensions. All right, X indicates the number of places. So here, 2X, diameter of 2500ths through, with a counter bore that is 3/8 that is going to be 1/4 inch deep. And it says 2X, that means for both holes. Okay, very simply, just creates for both holes there. And here, dimensioning a radial pattern, notice that we put in the angle here. Notice that there's a diameter here for this is really this diameter, because it's 2.25, this is probably a cylinder. That should be done in the longitudinal view. But also, you should be giving we're giving the radius right here. So the radius of this, and you have a circular tool in Inventor to put that up and put that into place. So a little bit more there, and we're going to practice some of this stuff so that you guys get a little bit more comfortable with it before you go off and you do your next big project. So that is advanced dimensioning and getting back to some lines and some other things and clearing things up.